Everyone, and we're going to continue with compound interest. I just wanted to make you aware that this section here that is in front of us is all about using the graphing calculator to solve compound interest formula questions. And given the current situation, I've decided to leave this portion out until you hit Math 53. So this is all about the graphing calculator. And we will address this when we get to Math 53. All right, that aside, let's continue using the compound interest formula to solve all of the problems that we've been working on to this point. A little reminder that whenever you see a question that has the word compounded in it, that's when you're guided that you need to use the compound interest formula. So let's look at the next question. We're just going to not be using the TVM solver. We won't be using technology. We will instead just be using the formula, the compound interest formula. To solve all of the following examples. Alrighty, so it says, use the compound interest formula to determine the value of an investment of $16.50 at 3.2% compounded semi-annually after 4 years. So as we can see, the word compounded is in the question, and we know that we have a formula for compound interest. It is F is equal to P, 1 plus I over M to the MT. And all we have to do is identify all of the variables and substitute into the formula properly and solve for what we want. So we want to find the value of the investment. So that means that we're seeking the future value. And we're starting off with $16.50. So our present value is $16.50. Our interest is 3.2%, so we know that I as a decimal is 0.032, and we are compounding semi-annually. Semi-annually means that it is happening twice a year, and our time duration is 4 years. All right, so now we can substitute into our formula. We know that P is $16.50, and we know that I is 0.032, and M is 2, and time is 4. And I might just take a moment and break down this so that it's a little bit cleaner to put into our calculator. So I'm going to solve for what's inside the brackets. And I'm left with 1.016. And I'll simplify that exponent, and now we can just punch this into our calculator. And again, when I'm punching this in, it's going to be 1650 times 1.016 to the exponent 8. All right, let's find what that is. And our future value rounded to 2 decimal places is 1873 and 41 cents. All right, let's try this again, let's go back to example 3, and now we're finding the future value of $3,600 GIC after 270 days at 1.75% compounded semi-annually. All right, so again, I see the word compounded. I know that I require the future value, so the future value is what I want to find. I'm starting with a present value of $3,600. My time is 270 days. I know that I need to turn that into years, so I'm going to divide that by 365. Our interest rate is 1.75, so I'm going to turn that into a decimal by dividing by 100, and we are compounding semi-annually, so M is equal to 2. All right, one more time, get my compound interest formula. Substitute in all of the values that I know. P is 3,600. I is 0.0175. m is 2, and our exponent is a little bit more complicated. I'm just going to do it in red. It is 2 bracket 270. Just do it over here. 2 times 270 over 365. Alrighty. So let's clean this up again just so it looks a little bit nicer on the next line and is a little bit easier to put into our calculator. So I'm going to crunch out that inside part of the brackets. And I get 1.00875. And I can also simplify my exponent to be 540 over 365. All right, and now we can just punch this in our calculator. For a future value of 3,646.70. And just a little reminder that this is the only spot where we round our decimals. All other spots are not rounded until we get to that final answer. All right, let's try an example that's a little bit harder, where we have to count time. It says, how much will a deposit of $17,500 made into a registered retirement savings plan from March 13th, 2015 to December 13th, 2020 at 4.8% compounded quarterly be worth? All right, so we know that we're going to be using our compound interest formula because we see that guiding word of compounded. And so I can write down my compound interest formula. We can identify all the variables that we've been given. So we see that we're starting with a present value of 17,500 and that we have an interest rate of 4.8%. So as a decimal, it's 0.048. And we see that we're compounding quarterly. So m is equal to 4. Now the hard part about this example is that we are counting some time. And we saw that in simple interest, when we counted time, we actually counted the exact amount of days. But we don't do that in compound interest without having technology. When we're counting time in compound interest, we just count time to the nearest month. All right, so I'm just going to draw myself a little timeline to give myself an idea of what's going on. I would suggest that you count from wherever you're starting. So we have March 13th, 2015 to the following March 13th of the closest year. So you have to determine what comes first. We know we need to get to December. So we have to say, we know what comes first. Does March come first or does December come first? And clearly it's March that comes first. So we're going to count to March 13th, 2026. And this way we can get the full number of years that we have. So in this duration right here, we see that we have 11 years total. And so now we just want to count up to, December 13th by month. All right, so we have March and then April, May, June, July, August, September, October, November, December. All right, so March, April, May, June, July, August, September, October, November, and December. Now, when you are counting months, you're not counting the ticks that occur, but instead you are counting the space between. So let's look at how many months given the space between that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces between. So we see that we have 11 years and 9 months. All right, so now we can go back to our formula. So our future value is equal to 17,500, 1 plus 0.048 over 4, and my exponent is 4 times 11 years and 9 months. All right, let's make this just be a little bit nicer. So 17,500, we can simplify what's happening in the brackets. It is 1.012. And this is a pretty complicated exponent for our calculator to take. So we may consider simplifying this down a little bit in a number of different ways. We could take our calculator and use our fraction key and go 11 ABC 9 ABC 12, and then multiply that by 4. To get our exponent, or we could enter it in the way that your particular calculator takes it by adding the 9/12 to 11, and then multiply it by 4 to give us an exponent of 47. All right, and then we can get to our final value now that this is just cleaned up a little bit to get into our calculator. For a future value of $30,656.47. Okay, let's try another one of those counting days again, or counting months. So it says a $35,000 student loan dated September 9th, 2018 is payable together with interest at 9.5% compounded semi-annually on June 9th, 2021. And notice that all of these examples are counting from, the 9th to the 9th, so that we can just, in compound interest, count to the nearest month. All right, so as before, time is our biggest issue because we know that the present value is 35,000. We know that we're looking for an interest rate of 0.095. We see that we're compounding semi-annually, and time is the piece that causes us a little bit of a challenge. All right, so we're starting on September 9th, 2018. And I'm suggesting that we want to count to the closest September, and we have to determine what comes first. Does September come first, or June in the cycle of 2021? All right, so we have September 9th, 19, September 9th, 2020. And if we go to September 9th, 2021, we will have counted past the June 9th, 2021. So we're going to stop here and count up to that June 9th, 2021. We can see, to start, that we have a full 2 years. And again, to determine time on a timeline, we are counting the space between. And now we need to count up to the June 9th, 2020. So we have, October 2020, November 2020, December, January 2021, February, March, April, May, and June 2021. And now again, we can count the spaces between, and we see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 months that occur in this time interval. So we have a time interval of 2 years and 9 months. So the key to counting time is to count from whatever date you're starting on, in this case September, to the closest September that happens before. And after, then you count up by the number of months. All right, we can take our compound interest formula, substitute in our variables for numbers. Again, we have another complicated exponent that we may want to clean up a little bit so it's easier to get in our calculator. And this comes out to 5.5. And then we can get our final answer. And we're going to round that final answer, and only that final answer, to 2 decimal places. So it is 45,176 and 77 cents. All right, I'm going to end this video right here and come back and start another video with 2-step problems. See you in a little bit.